In this video, we will demonstrate how to interface an LCD using PIC microcontroller. We will learn how to program an LCD to display the word hello and then implement this on Proteus. Let us open the PlabX IDE and create a new project with the name LCD Interfacing. Open the assembly file. The program will begin by including the header files for PIC 18F452 microcontroller. List directive tells the assembler about some options such as hex file format. We have already configured some of our variables such as crystal oscillator and watchdog timer. Next, we will define our origin. The variables used in our program will be defined next. We have defined labels for port D and port B and for some other variables as well as shown. In the main program, port D and port B will be defined as output port by clearing their tris registers. Our port D will be connected to the LCD data pins and 3 bits port B pin 012 will be connected to the command pins of the LCD. Before sending any commands or data to our LCD, we need to initialize our LCD, so we have created a delay named as delay long delay for approximately 1 second. Then we will send our commands such as defining our LCD as 2 lines and 5x7 matrix, display on cursor blinking, clear display screen, and then force cursor at the 6th position of the first line. The codes of these command lines can be obtained from this table. So for example, we have sent code 38 in order to define LCD as 2 lines and 5x7 matrix. Then we will call our command subroutine. We will discuss this subroutine later. Before sending our next command, we have to wait for 5 to 10 milliseconds and hence calling a delay subroutine. So after sending each command, we will now send our data to the LCD. Since we are displaying word hello to our LCD, we will send each character one by one as shown. Similar to the command instruction, we will call the delay function before sending our next data. We will now look at our command and data subroutines. In the command subroutine, we will move our data to PORTD. We have named this port as LCD data. Next, we will set the bits of the command pins. The RS and RW bit will be set to 0. And then we will send a high to low pulse to our enabling pin. Between each high to low pulse, there should be a delay of at least 450 nanoseconds or more. Similarly, for data subroutine, we have to set RS value to 1, RW to 0, and then send a high to low pulse to the enabling pin. Without sending pulse to the enabling pin, data will not move to the LCD. We have to make 3 delays as long, short, and normal delay. Please refer to my previous videos for details on the delay subroutines. Now we have made our program, let us now implement this on Proteus. So open the Proteus environment. Select the PIC microcontroller and then select the required LCD. We will select LM16L. Connect the terminals of port D with the data pins of the LCD. Data pins are from pin 7 to pin 14. Next, connect the 0, 1, and 2 bit of port B to the RS, RW, and E pin of the LCD as shown. Now we have to power our microcontroller and LCD, so 5V to the VSS pin and ground to the VDD pin. Pin 1 of the microcontroller will be given 5V as well. We will then load our program to the microcontroller which we have just created. Now let's simulate this project. As we can see, the word hello is displayed in our LCD. Thanks for watching this video. If you do like this video, please subscribe to my YouTube channel.